Let's do problem 51 on page 222. And I'll read it from the book. It's a pretty basic problem. There's number 51 right here. It says, what is the angular momentum of a 0.210 kilogram ball rotating on the end of a thin string in a circle of radius 1.1 meter at an angular speed of 10.4 radians per second? And so, I made a mistake here. This is wrong. I knew I wrote something wrong. The radius was, what did it say? 1.1 meter. Okay, so we got a ball on the end of a string. We're spinning it around at this angular velocity. It has this mass and it has this radius. And we want the angular momentum. So we start with the angular momentum equation. Angular momentum equals I times omega. And, or iota, I should say. All right, and then, so, this is a particle. It's just a single particle. If you have a particle or a system of particles, you just multiply MIRI squared. But there's only one. I don't have to add anything. I just have the one thing. So that's just going to be the mass. And I'm going to multiply that times the angular velocity. And notice the angular velocity is already in radians per second. I'm sorry, the radius. I'm getting ahead of myself. 10 meters squared. And so now we have I 0.210 times 1.10. You got to remember to square that. And I got 0.2541 kilogram meter squared. So L is equal to 0.2541 kilogram meter squared times 10.4 radians per second. So I just have to take that times 10.4, and I get 2.64. And what are the units? Kilogram meter squared per second. If you want to put the radian in there, you can. It's not wrong to do that, radians, but you can just leave it with kilogram meter squared per second. And that's my answer. I think the only mistake that I noticed people making on this was a few people thought we were talking about rotational kinetic energy. It's a different formula, a different thing altogether. Any questions? And also some people put a 1/2 in here like this was a disk instead of a particle. You got to look at what the object is and know how to calculate its rotational inertia. If it's a particle, it's just mr squared. If it's a disk, 1/2 mr squared, a sphere, 2/5, and so on, but you can always look those up. Any questions? Okay, that is all.